So looking at this function, I noticed a couple of things. I noticed the 2 in the numerator tells me it's going to be vertically stretched. So all my y values, because it's vertical, are going to increase. They're going to double. And this -1 right here is on the outside. It's not in the fraction at all. So that tells me it's going to translate, and because it's outside the output, it's going to translate down 1. So I'm going to start with the vertically stretched part, and then all I have to do is just take all those points and slide them down by 1. So if I plug in 2, or -2, 2 divided by -2 is going to give me -1. Or I plug in -1, 2 divided by -1 is going to give me -2 because those flip. If I have 2 divided by 1/2, 2 divided by 1/2 is going to give me 4. If I plug in 4, 2 over 4 is 1/2. And remember, if one's negative, they're both negative because this is going to be in quadrants 1 and 3. So I'm not going to stress about the positives and negatives. I just know it has to be in quadrants 1 and 3. So if I start graphing, I have 2, 1, 1, 2. So 2, 1, 1, 2. And then over here, 1, -2, -1, -2, -2, -1. And then I have 4, 1/2, 4. So I'm basically just taking what's over here and then copy pasting over there. It's just reflecting across. Okay, so remember though, that this isn't actually where my graph is going to be, because that -1 means that I'm going to take all of these points and translate it down 1. So my asymptotes were right here, the y-axis and the x-axis. But what happens when I translate this whole graph down by 1? Well, the y-axis is still an asymptote, but that x-axis has now gone down to this right here. That line is now my new asymptote, which is y equals -1. So my x-intercept I can see is 2. My y-intercept, it doesn't have 1, so NA. My asymptotes, I have 2 of them. I have the y-axis is 1. Remember, that's just x equals 0 is your y-axis. And then my other one is y equals -1. So the y-axis, there's my vertical asymptote. This is my horizontal asymptote. And the asymptotes are going to tell me about the domain and the range. So for the domain, x can be anything but 1, because I can't plug, or x can be anything but 0. I don't know why I keep saying 1, y'all. Anyways, x equals 0, so x can be anything but 0, because if you plug in 0, 2 divided by 0 is undefined. So I'm going to write it out like that. And my range, y could be anything but -1. That's it. So I take my asymptotes, I basically just put a slash through it when I copy and paste it to domain and range, because it cannot equal those values. That's it. Okay, taking a look at this one. This -1 tells me it's going to now be not in quadrants 1 and 3, but now it's going to be in quadrants 2 and 4. So it flips, it reflects. And you could say reflects across the x-axis. You could say reflects across the y-axis. A negative in the numerator is the same thing as a negative in the denominator. And then this -1 right here, it's not outside of the fraction, it's within the fraction. So that tells me it's going to translate. And it's not going to go left 1, it's actually going to go right 1. So that goes back to this one that we had up here, where it was outside, so it's up or down, outside, up or down, within the fraction, right or left. So going back to the parent function, I'm not vertically stretching it, compressing it. I just know that what was here and here is now going to be switched to be there and there, but it's not going to look like that. So if I plug in 1, starting with the negatives, I have 1, 1 is a point. I have 2, 1/2, 1/2, 2, 3, 1/3, 1/3, 3. This is my parent function, 1 over x. That's the table that I'm making right now. But instead of 1, 1, it's now going to be 1, -1, or -1, 1. And then it's not going to be 2 1/2. It's going to be 2 negative 1/2, or 1/2 negative 2. And so I'm going to go ahead and make those curves, knowing that I have to slide this because I have to translate it right 1. So it's not going to stay here. It's going to translate right 1, which is nice and kind of easy to do when I'm on the iPad. So right there, there's my asymptotes. But when I take this and I move it right 1, now it's the x-axis that stays the same and it's the y-axis that changes. So going through my x-intercept, I don't have one because that asymptote didn't change. My y-intercept is at 1. And if worst case scenario, you could plug in points to get those answers. If I plug in -1 over 0 minus 1, 0 minus 1 is -1. -1 over -1 is 1. But in this case, it was nice. It was easy to tell from my graph. Okay, my horizontal asymptote, which is just an asymptote, just horizontal, is my x-axis, or y equals 0. My vertical asymptote has now shifted. So it's not the y-axis anymore. Now it's where x equals 1. So that helps me out. My vertical asymptote helps me out with my domain. My horizontal asymptote helps me out with my range. It's kind of opposite flipped from what you think. So my domain, x can be anything but 1. Because I slid it over, so I can't have a point right there. So that's my asymptote. My range, y can be anything but 0. And that's how you graph these functions. I like to start with a vertical stretch or compression and then just slide it to wherever it needs to go. So taking a look at this one, the -1 tells me it's going to be in quadrants 2 and 4. Yeah, 2 and 4. The +2 right here tells me it's going to translate not right, but left 2 because it's in the fraction. And the -4 outside tells me it's going to translate down 4. So start with your original, but no, it's going to be in these quadrants. So 1 and 1, 1/2, 2, -2, 1/2. I don't need to have a million points. Just a couple gives me a good idea. Remember, asymptote means it gets really close, and sometimes my graphs will kind of curve a little bit, but just know in theory it's getting closer and closer and closer, but not actually touching, which is hard to sketch out on a graph. So I have my vertical asymptote is the y-axis. My horizontal asymptote is the x-axis. And I already reflected it because it was in quadrants. It's supposed to be 1 and 2, but now I'm doing 2 and 3. But now I'm going to translate this down 4 and left 2. So I'm going to go left 2, so 1, 2, and then down 4. 1, 2, 3, 4. So x-intercept, I can't tell exactly where it's at. Y-intercept, I can't tell exactly where it's at. So remember, to find the x-intercept, plug in 0 for y and work backwards. So if I have 0 equals -1 over x plus 2 minus 4, add the 4, so I get 4 equals -1 over x plus 2. Turn into a proportion and cross multiply, so I get 4x, I'm multiplying that whole thing by that. So I get 4x plus 8 equals -1. Subtract 8, so 4x equals -9. Divide both sides by 4, and so my x-intercept is going to be -9 over 4, which as a decimal is -2.25. So I can go and look at this and double check. Does that look like it's at -2.25? Yeah, it's right around there, so I'm in the right spot. For my y-intercept, I'm going to plug in 0 for x. So instead of 0 for y, now I'm doing 0 for x. So I have y equals -1 over 0 plus 2 minus 4. 0 plus 2 is 2, so I have -1/2 minus 4. -1/2 minus 4 is -4.5, which as a fraction would be -9/2. 2 times 4 is 8. 8 plus 1 is 9, so -9/2, which as a decimal is -4.5. If we look, I'm in the right spot. So I'm on a roll with that. Okay, my asymptotes have now changed. So My horizontal asymptote is now right here where y equals -4. And my vertical asymptote is right here where x equals -2. Because it translated left 2, so -2, down 4, -4. Notice that pattern there. So those asymptotes tell you where your graph is supposed to be, and they also tell you what that shift is in your original function. And so once I have my asymptotes, then I can do my domain and my range. My domain, x is anything but -2. Which if you wanted to write it in that interval form, you could say from -infinity to -2 parentheses union -2 to +infinity. Just putting that -2 right there. And my range, y would be anything but -4. In that interval notation, -infinity to -4 union -4 to infinity. Putting that same thing there and there. So down here, it shows you where the asymptotes are. So what's the equation? Now I'm going backwards. So if I look at this graph, I have to be careful because it's going by a scale of 2. So one of my asymptotes is x equals -3. It's my vertical one. And then 2, 4, I have y equals 4. So it's going to go left 3 and up 4. So left 3 means that in the fraction right there, that x, I'm going to add 3 to it because I'm doing the opposite. So y equals 2 over x plus 3. Up 4, outside, plus 4. And that's how I write it. Okay, dealing with this one, this goes right 1, so x equals 1. And this goes down 4, so y equals -4. So y equals 2 over x equals 1 would be x minus 1. The x changes the fraction part, so 2 over x minus 1. And down 4, that -4 goes on the outside, and that's it. So if you know where it slides around, it kind of goes back to that last one. That sliding around really helps you tell where does the fraction go. Or where does it go within the fraction.